Hello everyone, I'm Vibhor Singh, and today we'll be discussing the 17th problem of the CP-31 sheet under the 1300 rated parameter. So as you can see, this is the CP-31 sheet and the 1300 rated problems have been selected. And this is the 17th problem, strange birthday party. Petya organized a strange birthday party. He invited n friends and assigned an integer ki to the ith of them. Now Petya would like to give a present to each of them. In the nearby shop, there are m unique presents available. The jth present costs Cj dollars, and our C1 is less than equal to C2 less than equal to Cm. Basically, it's a sorted vector of costs, and it's not allowed to buy a single present more than once. For the ith friend, Petya can either buy them a present j less than equal to ki, which costs Cj dollars, or give them Cki dollars directly. And we have to help Petya determine the minimum total cost of hosting his party. Okay, so let's try to understand the problem using this first example where you have 5, 4, and then 2, 3, 4, 3, 2, and 3, 5, 12, 20. So this is the first example where 5 is n, that is the number of friends, and 4 is m, that is the number of presents we have available. Then is the k vector, that is the number assigned to each of the friends, and then is the c vector, which is the cost of each of the presents. Now one thing we know that c vector will always be sorted. This is given to us in the question, so we can keep that in mind. Now what does the k vector represent, or the values given to each of the friend represent? Let's say the first person has k equal to 2. That means I can either buy the first or the second present for this person. That is, buy any present less than 2, right? So C1 or C2 we can buy for the first person, or we can give the first person C of k of I, that is C of $2. That is, I can give this person $5. So I can either buy a present of $3, buy a present of $5, or give them $5 directly. Similarly, if you look at the second person, the value of ki is 3. So I can either buy the first, second, or third present, that is C1, C2, or C3 presents, or I can give him C3, right? Because ki is 3, so I can give the person $12 directly. Then if I look at the next person, that is 4, then I'll have all the 4 options, or I can give them $20, that is CKI dollars. So I hope this is clear that how we can give presents, what options do we have for each person, right? We can either give them dollars we can either give them a present with value less than, or present index less than what the number is given to them, or we can give them the same value cost of the present with index ki to them and dollars directly in the money, right? So that is the two options we have. So like one sample thing that is given to us, that is, let's say for the first person I gave them $5. So first person I gave them $5. Second person I gave them this present as the third present, basically third present, which is $12. Okay, then third person, that is, so this is the second person we have done till now. Now for the third person, let's say I gave him the first present, that is first present. So this person gets $3, or we have spent $3 on this person rather. Then the next person, I gave him this person the second present. So for fourth person, I gave this person the second present, which is $5. And the last person, I give him $5 instead of buying a present, that is CKI dollars directly, right? The fifth person, I give them $5. So overall cost became 5 plus 5, 10, 15, 18, and plus 12 is equal to 30, right? So the overall cost is 30 that we require for the party. And this is the best arrangement, or one of the best arrangements, because the best answer is given to us as 30, right? So how are we coming to the best answer? I think we'll understand that when we start forming the solutions. But you can try different variations and you'll realize that you cannot get any answer better than 30 with the given constraints in the problem. So I hope this part is clear. Basically, we use these first 3 presents, and to 2 people we have just given dollars directly, right? So we have used both the options and we have to use it optimally. Now how to use it optimally we can understand while understanding the solution. Now let's try to understand the expected time complexity. We are given t as the number of test cases go till 10 raised to 3, and then m are till 10 raised to 5, 3 into 10 raised to 5. and it is given that the sum of n is not greater than 3 into 10 raised to 5, and sum of m is also not greater than 3 into 10 raised to 5 over all test cases, right? So 1 second in Codeforces corresponds to approximately 10 raised to 8 operations. Now you're given n and m both go till 3 into 10 raised to 5. Okay. So anything of this order of n plus m, order of n log n plus m, something like that, or m log m also over here, something like this will work. But as soon as we go to some higher complexity such as order of n into m or order of n square and or m square, this will lead to TLE. So we can draw a line here that anything in the linear or logarithmic forms is fine, but I cannot use n into m or n square or m square. So that's it for the expected time complexity discussion. Now let's try to understand how we can solve the problem. So first thing is, let's just see, k is a random value, right? Like the order of the persons don't matter to us, right? We can choose any option, that is we can either give the person a present or give them dollars directly. We can choose any option. There is no constraint on that, right? So first thing I would want to do is, let's sort this value, sort the people on the basis of their ki values, because that will give us a better understanding of the problem, right? Let's just sort it. 2 2, so we have 2 2 3 3 and 4, 3 3 and 4, right? We have 2 2 3 3 and 4, and we have 3 5 12 and 20. So 3 5 12 and 20. Okay, now why are we sorting this, or what is the intuition behind this? Basically, what our observation is, or what we can observe is, whatever ki value is, that many presents from the start are available to me for this person. Okay, so for the first person I have 2 presents available. Now for this person with ki2 I have 2 presents available. Next person with ki3 I have first 3 presents available, right? Similarly for the next person, and for the last person now I have all 4 available, right? So I have just changed the ordering of ki, but overall problem won't change for me, right? Because it doesn't matter in which order I solve for each person, right? So that is why that is from where we get the intuition. Let's just sort the values on basis of ki first, so that maybe it will help us understand the problem better. So each ki value represents that we can give first ki presents to this person, right? So we are looking at like the first condition where we can give presents, right? We can give presents. We can give some present, and that could be less than or equal to the ki present, right? Now, our second condition that we could have, or the second case that we could have is, or the second thing that we can look at is, we will give dollars to the person, right? Now, how many dollars do we have to give to each person? See, for the first person, so let's just remove this part over here. See, so for the dollars part, for the first person, I can give them C ki dollars. That is, I can give them $5, right? Second person, again, I can give $5. Then the third person, that is after sorting the third person, I can give them $12 if I'm looking at the second condition, right? So let's just remove this from here so that we don't get confused. So for the third person and the fourth person, I can give them $12, and for the fifth person, I can give him $20, right? So for the first case we saw, we have first ki available presents. For the second case, we observed that we have to give CKI dollars directly. Now we know that these values are sorted, right? That is, CI values are sorted. That is given to us in the question, right? So whoever has greater ki value, for them, I will need to give them greater amount of dollars, right? Which is not a good option for us. See, for each person, or for each higher ki value, I will need to give that person more number of dollars, right? So that is not good for us, since we want to minimize dollars, or we want to minimize our overall cost, right? So that is one observation we have, that higher ki value leads to higher cost if we give dollars, right? So This is our observation that the higher ki values will require higher cost of ki dollars. Now we want to minimize the overall cost, right? We want to minimize the overall cost. So first thing that we should think of is our optimal case would be that we don't choose giving dollars to the higher values. That is, we try to give them presents first. Whoever has higher ki, I should prefer to give them a present rather than giving them dollars directly, right? Because see, we have 4 presents, we can have less number of presents than people, right? We can have more as well. But whenever we have the option between giving a present or giving the dollars, it is optimal to give the higher ki value the presents and the lower ki value the dollars if we are forced to give dollars, right? So like for if I'm looking at the second person or the first person, if I'm forced to give this person dollars, I can give them only $5. Versus if I'm forced to give the fourth person or the fifth person rather, if I'm forced to give the fifth person dollars, I'll need to give him $20. So that will be a much higher cost for us. So that is our observation, that higher ki value leads to a higher cost of dollars. So from here only we can build a greedy idea that that we will give the present with least values or least costs to highest KIs. Now why are we doing this? See, as we saw, higher KI will require more number of dollars if we don't give them a present. So it is better for us to give them a present as long as we can, right? The smaller present, we can give it to them. But you'll be like, why are we giving them the smallest present? Won't it help us later on? So let's try to see that case. In this example itself, let's use this example itself. That is, we have 2, 2, 3, 3, and 4. And we have 3, 5, 12, and 20, right? So what we are saying is that to the highest person, we should give the smallest present, right? Then to the second highest person, we should give the second smallest present. Third highest person, third smallest present. And we will do this till some point. Now, when I come to this person, I know I have the fourth present left. And since the cost of giving this person is only $5, I know I should give them $5 directly. And also, I'm not allowed to give them this fourth present because if I choose J as 4, my 4 would be greater than Ki, right? Where Ki is 2. So I cannot give this person this present also. And even if I could give this person the present, it is better for me to give this person $5, right? So that is the case we have. For each higher value, we will try to give them the present. And for each lower value, we will just give them their respective CKI dollars. So let's look at a case where, or let's try to say that I won't give this person or the highest KI value the least present or the smallest present. Let's try to see what happens then, right? So let's say I give this person the smallest present. So I give the fourth person the smallest present. Then I gave the third person the second smallest present. Then I gave the fourth person the third smallest present, right? Let's just say I did this thing, and the second and the first person, I will give them $5 each. So what will our cost become? Okay, so let's see what will our cost become. See, for the third person, we gave them the first. So we'll give $3. We'll spend $3. Second, then the next person I gave 5. So I'll give $5. The next person I gave 12. So I'll spend $12. Then I'll give 5 and 5 to 2 and 2. So it will be 5 and 5, right? So we are getting the same solution of 30, right? Basically, we are giving only these 3 people the presents. So we are getting 30, which was the same thing when I started giving smallest to this guy, right? That is what we saw earlier. If I give the smallest present to the last person, second smallest to second last person, third smallest to third last person, I was getting the same result, right? So I have to give to these 3 only, and I'll get the same result if I start with my greedy idea that if I take the first person to take the smallest present. Now let's look at the counter way that these 3 don't get the present, someone else gets a present. Let's look at that case. Okay, so one of the first 2 people would get a present. What will happen then? Basically, let's say I gave this person the first present. That is the second person I gave the first present for 3. Okay. Then next for this person I gave them the next present, that is 5. Right. So I have used the first 2 presents. Now for the third person, let's say I gave them the third present. That is the only option we have, or we can give him $12 because first two presents are already used up in this case, right? So I'll spend $12 on this person. Then for the next person, I will need to spend $12, right? I have no other option. And for the last person, again, I'll need to spend $20. Either I buy the present or give the person $10 directly. I will need to buy it. And this value is definitely greater than 30, right? This value is definitely greater than 30. So from this, what do we observe? It is optimal for us to give the last people the first present. And how can we achieve this case in terms of if we are writing the code? We can give the last person the first present, second last person the second last present, so on and so forth till we should or till some point. And how do we find that point, right? The only part that remains is how do we find the point where we should stop giving them presents and giving them dollars. Okay, so let's see, we have two pointers, right? Basically one pointer starting from the end, one pointer starting from the start, that is 3 3 4 and then 3 5 12 20. So we have one pointer starting on this vector from the end, and we have another pointer starting from this vector on the start. Let's call this P, let's call this I. Okay. So for I equal to 1 and P equal to 0 or P equal to 1, I will have like I is equal to n minus 1 currently, but let's just, if we are starting from the right, so let's call I 1 right now. Okay. So I equal to 1 and P equal to 1, we will have that we should give them the present. For the next person, we should give them the present. Next person, we should give them the present, right? But like, how are we forming the condition? See, our condition would be that we should give the we should spend the lower number of dollars on each person, right? We should spend lower number of dollars. So now, how do we check this part? Like, how are we getting the lower number of dollars? Basically, to buy the present, the current pointer P, to buy the present, I would require CP cost, right? C of pointer P, that is the cost I'm required. And for giving the person dollars directly, I will be requiring CKI dollars, right? So if I look at the case of 4, that is I is equal to 4, right? So for first person, I equal to 1, P equal to 1, I gave the present. I equal to 2, P equal to 2, I gave them the present. I equal to 3, P equal to 3, I gave them the present. Now my P value is 4 and I value is also 4, right? So my CP becomes $20 and my CKI becomes $5, right? KI is 4, sorry, I is 4, so KI is 2, right? So, and P is 4, so CP is 20 and CKI is 5. So I know it is less, right? CKI is less. So in such a case, when I reach a condition where my CKI is less than CP, that is when I should start giving them CP dollars directly. I should start giving them CKI dollars directly rather than spending CP amount on a present. So this is our stop condition. This is the condition where we will be like, at this point, I should start giving, or when this condition holds true, I should start giving them, or I should give the person CKI dollars. So from here, we have the condition that we start our point, we'll have our structure of the code such that we start a pointer from the end on K vector. We'll start another pointer from at the start in our presence vector, right? Or the cost vector. And we will keep checking if C of P. So we will check that if C of P is less than or equal to C of K of I, then we should give the present, right? So we will buy present. In this case, we should buy present, right? We should buy the present, we should decrement I, and we should increment our present or available present pointer, right? Because we have already bought this present. Now the next present is available to us. And in the else part, so we have a if here, and then in the else part, we would have that, okay, I should just give them C of K of I dollars. I should just give the person C of K of I dollars. And I should increment, or I should continue decrementing I, right? I is starting from the end, that is why I'm decrementing I. In the explanation, I just took I1 for better understanding, but in the pseudocode or in the understanding of the overall code, we would be decrementing I because I is starting from the end of the vector, right? So now let's move on to the code of the problem. So we first take number of test cases as input, and then we take n and m as input. We take the vector k and vector c. So k is the k values or the value given to each person, and the vector c is the cost vector that we have taken as input, and then we sort based on the k values, right? So this is the first part of our solution where we sort based on case values. We are taking initially answer as 0 and p as 0. Note that I have defined int as long int because our answer value can exceed 10 raised to 9. That is why it is very important to define answer, either define answer as long or just define int as long or just override int as long, right? So I have defined int as long. That is why I won't face any issues here. Then for starting our I from n minus 1 to 0, right? So we are reverse iterating on our vector of people, right? So the first person will have the highest ki value, or the n minus 1 person would have the highest ki value, right? That is what we have. And p represents the current available present or the pointer on the presence. So if p is less than m, which is the first condition, that is we have not exceeded the total number of presents we have, and c of p is less than equal to k of c of k of I minus 1. We are doing k of I minus 1 because we have because just to handle the 1 base and 0 base indexing, right? So if c of p is less than equal to c of k of I minus 1, we will add c of p, that is we'll buy this present and we'll increment p, else we will not buy this present and we'll just give the person c of k of I minus $1. And then in the end we are printing the answer. So that is the overall solution to this problem. Now let's see what will be the time complexity of this problem or of this solution. See, taking the input over here is order of n, right? And then the input over here is order of m for taking the input of costs. Then sorting will take order of n log n. And then running this final for loop will run in order of n, since we just have the simple for loop which runs in order of n and no additional loops within. So overall time complexity of our solution just becomes, order of n log n plus m, right? And then overall space complexity, we have taken one vector of length n as input and another vector of length m as input. So overall space complexity becomes order of n plus m. So I hope the overall solution is clear to you. Thank you.